students, and welcome to today's lesson. I'm Miss Lee. Today, we will continue to investigate the question, how can we describe an object's motion? Are you ready? Grab your pencil and your science journal, and let's get started.
Do you remember when we visited these motion stations? We wrote down our observations in this chart. Do you notice any similar words in our observations? I noticed that at the car station, we used the word stop to describe the car's motion. Do you see the word stop anywhere else on our chart? Point to where you see the word. Oh, wow, we use that same word to describe the motion of the pendulum, the spinning toy, and the ramp. Hey, do you think the phrase does not move is similar to stop? I think so. Let's put these words together in a chart. Let's look at these sentences more closely. Hey, does not move and stop both describe objects that are not in motion or stopped. The words describe an object at rest. An object is at rest when it is not in motion. We saw the toy car roll, then slow down, and then finally come to rest. So we can change this heading from stopped to rest. Let's look at our observation chart again. Do you see any other words that are similar? Point to them on the screen. You know, we use the words fast and slow to describe the motion of the car. Do we use these words to describe the motion of any other objects? Point them out. Oh, wow, we also use fast or slow at the spinning toy station and the ramp station. What do the words in these sentences describe? What do you notice? Hey, we can say that these words describe how fast or slow each object goes, or the object's speed. Speed is the distance an object moves in a certain amount of time. At the car station, we saw the car's speed start out fast and then slow down. So do you think we should change the title of this section of our chart from how fast or slow to speed? I think so too. Sorting these words is fun. I wonder if we can find another similarity. Do you notice any words that are similar in our observation? Wait a minute. Look, the ball bounces up and down, and look at the car. It moves straight and its wheels moves in circles. Do you notice anything similar about these three phrases? These phrases sound like they describe which way the objects are moving. Do you see any words or phrases at the other stations that describe which way? We use straight at the ramp station and around in a circle at the spinning toy station. What else? I see so many. I see back and forth, down, and even some phrases like upside down, U-shape, or farther and farther away. All these words and phrases help us describe which way or the direction the objects move. Direction is the path along which an object moves. At the car station, the direction the toy car moves is in a straight line. So do you think maybe we should change the title which way to direction? I think so too. Wow, we describe the motion of objects in a variety of ways. Think about all the words and phrases we sorted today. What information do you need to describe the motion of an object? How can you gather that information? Your first task for today will be to answer these questions. Hey, I noticed that when we describe an object's speed, we use words like fast and slow. But do you think we can find a way to make our descriptions of speed more precise? I think we need to figure out how to measure speed. Let's revisit the car station and see if we can do an investigation that allows us to measure speed. How can we use a stopwatch and a meter stick to help us describe the motion of a toy car? Well, remember, to measure speed, we need to measure both distance and time. So let's use the meter stick to measure how far the car travels and a stopwatch to measure how long the car takes to travel that distance. I have two ramps and two of the same toy car. Car A is on a ramp that is 11 centimeters tall. Car B is on a ramp that is 6 centimeters tall. We'll investigate speed in two different ways. Let's first observe the time needed for each toy car to travel 150 centimeters. We'll let go of the car so that it rolls down the ramp. We'll start the stopwatch when the car reaches the floor. I use the meter stick to measure 150 centimeters and I put a finish line there. We'll stop the stopwatch when the car reaches the finish line. Which car do you think will cross the finish line first? Will car A on the 11 centimeter ramp or car B on the 6 centimeter ramp finish first? Let's find out. 3, 2, 1, go. Oh, wow. Car A travels 150 centimeters in 2 seconds, and car B travels 150 centimeters in 3 seconds. So which car traveled faster? How do you know? Well, both cars traveled 150 centimeters, but car A takes less time to travel the same distance. So car A is faster than car B. So if two objects travel the same distance, how can you compare their speed? The object with greater speed travels the distance in less time. So the object that takes more time is slower. Now let's change our investigation. This time, let's see how far each car travels in the same amount of time. 3 seconds. Just like last time, we'll start the stopwatch when the car reaches the floor. Which car do you think will travel further in 3 seconds? Car A or car B? Let's watch. Ready? 3, 2, 1, go. Oh, look. Car A travels 194 centimeters in 3 seconds, while car B travels 155 centimeters in 3 seconds. So which car traveled faster? How do you know? Car A traveled faster because it travels a farther distance in the same amount of time. So if two objects travel for the same amount of time, how can you compare their speeds? When objects travel for the same amount of time, the object with greater speed travels farther. The object that travels slower goes a shorter distance. Wow, we've learned so much already. Your second task for today is to summarize your knowledge of motion. Be sure to include the words direction, speed, and rest in your summary. Think about the objects you observed at the stations. Which objects do you think had energy? I think all the objects that moved at the stations had energy. We know that energy is necessary to make something happen, and we saw something happen at all of the stations. The objects at the station had a form of energy called mechanical energy. Mechanical energy is energy from where an object is or what an object is doing. Energy from an object's motion is one type of mechanical energy. Can you think of any examples of mechanical energy that you have observed in your everyday life? Have you ever been on a school bus? A school bus has mechanical energy when it moves down the road. And hey, a classroom door has mechanical energy when it opens and closes. I can think of something else that has mechanical energy. The cars from our investigation have mechanical energy. Do you notice that even though our two cars moved at different speeds, we could still describe their motion in the same basic way? The cars went down the ramp and then moved in a straight line until they stopped. If two objects move in similar ways, will descriptions of their motion always be the same? I think we need to investigate this question further. And in our next lesson, that's exactly what we'll do. Let's review your tasks for today. First, answer the questions about describing motion. Second, summarize what you learned about motion in this lesson.